So the objectives for this unit are going to be learning the reasons for sampling, developing an understanding about different sampling methods, distinguishing between probability.
Shafiq, we are not hearing. No sound.
Results with known accuracy that can be calculated.
Can you hear it now?
Means.
Yes, but the volume is down.
What we have to consider is a sampling frame.
I think it's okay.
List from which the potential respondents are drawn, whether that be a registrar's office, class roster, a class of students, or students at a particular school, for instance.
Can you take it to the beginning so that we start?
Such as university. Welcome to Unit 2 on sampling methods. So the objectives for this unit are going to be learning the reasons for sampling, developing an understanding about different sampling methods, distinguishing between probability and non-probability sampling, and the relative advantages and disadvantages of each of these approaches. As we know, a sample is a smaller representation of a larger population that still is able to determine truths about that smaller population. Why do we sample? Because number one, we have lack of resources, which might be time or money, as well as workload implications and busy schedules. A sample also gives results with known accuracy that can be calculated through different statistical means. Something that we have to consider is a sampling frame, which is the list from which the potential respondents are drawn, whether that be a registrar's office, class roster, a class of students, or students at a particular school, for instance. Sampling frame errors, such as university versus personal email addresses, changing class rosters, those sorts of things, you have to ensure that all the students in the population of interest are actually represented in your sample. There's three factors that influence a sample's representative nature. The first is the sampling procedure, another is sample size, and the last is the participation or the response, the return of whether it be a survey or consent, permission, that sort of thing. When might you sample the entire population? When the population is small, when you have lots of resources and money to conduct these research projects, as well as when you may not expect a very high response. If we break down a sample, we have to think about who do we want to generalize to, and what population can I potentially gain access to? How might I do that? And who's going to be actually in the study that I'm going to be investigating? So we go from a theoretical population to the actual study population. And then the sampling frame that we consider all goes into actually selecting your sample. This is a visual that I like to use where you think about the target population is the whole group, and the study population is a smaller representation of that group that hopefully you can generalize to, and a sample is going to be a component of that study population. There are several types of probability samples. These include simple random samples, such as systematic random, stratified random, multi-stage samples, multi-phase samples, and cluster samples, as well as non-probability samples, such as convenience and quota-based samples. We're going to go through each of these. Again, when you sample, you need to consider several things. First, defining the overall population of concern, which was addressed in the other PowerPoint that we did this week. Second, specifying a sample frame or a set of items or events possible to measure. Third, specifying a sampling method. Fourth, determining the sample size. Fifth, implementing the sampling plan. Sixth, sampling and data collecting. And finally, seventh, reviewing the sampling process. So again, your sampling frame it has the property that we can identify every single element and include in our sample. The sampling frame must be representative of the overall population. And it's possible to identify and measure every single item in the population and to include any of them in our sample. However, more than likely, this is not going to be possible. So again, we do the best we can to still represent the overall population. In probability sampling, in this scheme rather, it's one in which every unit in the population has a chance that is greater than 0 of being selected for the sample. When every element in the population does have the same probability, it's known as equal probability of selection, EPS. That kind of design is also referred to as self-weighting because all the sample units are given the same weight. Again, these are the types of probability samples that we'll go through now. In non-probability samples, it's where some elements have no chance of being selected. It also involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. For example, if we visit every household on a given street and interview the first person to answer the door, in any household with more than one occupant, this is a non-probability sample because some people are more likely to answer the door. That is, those who are unemployed, perhaps mothers at home taking care of kids, etc. Non-probability samples include accidental sampling, quota sampling, and purposive sampling. In addition, non-response effects may turn any probability design into non-probability design if the characteristics of non-response or responses are not well understood, since non-responses effectively modify each element's probability of being sampled. In simple random sampling, this is applicable when a population is small, homogeneous, and readily available. It provides for the greatest number of possible samples. This is done by assigning a number to each unit in the sampling frame. A table of random number or lottery system is used to determine which units are selected. In this case, estimates are easy to calculate, and simple random sampling is always an EPS design. Some of the disadvantages are if the sampling frame is large, this method might be impractical. Minority subgroups of interest in the population may not be present in the study in sufficient numbers for the actual overall study. We have to consider the replacement of selected units. For example, if we catch fish, measure them, and immediately return them to the water before continuing with the sample, this is a WR design. This is meaning with replacement. So just like in elementary mathematics, we have to consider with or without replacement in regards to a sample. Systematic sampling relies on arranging the target population according to some ordering scheme and then selecting elements at regular intervals through that ordered list. In this case, we have to think about the fact that it's important that a starting point is not automatically the first on the list, but is instead randomly chosen from within the first to the X element in that list. So that a simple example would be to select every 10th name from the telephone book, also referred to as sampling, with a skip of 10. Systematic sampling is an EPS method, as we said, because all elements have the same probability of selection. It is not simple random sampling because different subsets of the same size have different selection probabilities. Example, in this picture here below, The set has 1 in 10 probability of selection, but the set has 0 probability of selection. So if it's every third person in this picture, some people have 0 probability of selection. The systematic sampling has several advantages. The sample is easy to select, it's a suitable sampling frame that can be identified easily, and the sample is evenly spread over the entire reference population. The sample may be biased, however, so this is a disadvantage if hidden periodicity in population coincides with that of selection. And it also may be difficult to assess the precision of estimates from one survey. A stratified sample is one where a population embraces a number of distinct categories. The frame can be organized into separate strata. Each stratum is then sampled as an independent subpopulation. Every unit in a stratum has the same chance of being selected. In stratified sampling, since each stratum is treated as an independent population, different sampling approaches can be applied to different strata. Some drawbacks include using stratified sampling, the sampling frame of the entire population has to be prepared separately for each stratum. Also, when examining multiple criteria, stratifying variables may be related to some but not others, which further complicates the design and potentially reduces the utility of the strata. Finally, in some cases, stratified sampling can potentially require a larger sample than would other methods. The post-stratification. Stratification is sometimes introduced after the sampling phase in this way. This approach is typically implemented due to the lack of prior knowledge of an appropriate stratifying variable, or when the experimenter lacks the necessary information to create a stratifying variable during the sampling phase. Sometimes we have an incident of oversampling. Choice-based sampling is one of the stratified sampling strategies. In this, data are stratified on the target, and a sample is taken from each strata so that a rare target class will be more represented in the sample, thus creating a biased sample. The effects of the input variables on the target are often estimated with more precision with the choice-based sample. Cluster sampling, on the other hand, is an example of two-stage sampling. First stage, a sample of areas is chosen, and in the second stage, a sample of respondents within those areas is selected. A population can be divided into clusters of homogeneous units, usually based on geographical continuity. Sampling units are groups rather than individuals, and a sample of such clusters is then selected. All units from the selected clusters are studied. Some advantages include the fact that it can cut down on the cost of preparing a sampling frame, and the fact that this can reduce travel and other administrative costs to create a functional sample. Disadvantages include sampling error may be higher for a simple random sample of the same size, often used to evaluate vaccinations, coverage, free and reduced coverage, those sorts of things within large populations. Cluster sampling requires the identification of clusters. For example, list all cities, towns, villages, and wards of cities with their populations falling in the target area under study, calculating a cumulative population and then dividing it by 30. This gives the sampling interval. Selecting a random number less than or equal to sampling intervals having the same number of digits, forming the first cluster, and random numbers plus the sampling interval equals the population of the second cluster. This sort of process allows for the identification of clusters to occur. In cluster sampling, there's two types of cluster sampling methods. One-stage sampling involves all of the elements within the selected clusters are included in the sample. The second one is the two-stage sampling. A subset of elements within selected clusters are randomly selected for inclusion in that sample. The difference between strata and clusters is that although strata and clusters are both non-overlapping subsets of the overall population, they differ in several ways. All strata are represented in the sample, but only a subset of clusters are in that same sample. With stratified sampling, the best survey results occur when elements within strata are internally homogeneous. However, with cluster sampling, the best results occur when elements within clusters are internally heterogeneous. Multi-stage sampling. Complex form of cluster sampling in which two or more levels of units are embedded, one in the other. The first stage involves a random number of districts chosen in all states, followed by a random number of villages. Then the third stage might include the unit being the houses, and all ultimate units selected as the last step in the survey process. Multi-stage sampling. This technique is essentially the process of taking random samples of preceding random samples. Multi-stage sampling is used frequently when a complete list of all members of the population does not exist or is not appropriate. Moreover, by avoiding the use of all sample units in a selected cluster, multi-stage sampling avoids the large and perhaps unnecessary cost associated with traditional cluster samples. Part of the information collected in a whole sample and part from a subsample. In this way, in the first phase, there are some surveys handed out, and in the phase 2, there are x-rays given to these, some of the cases, and then finally in phase 3, there's a sputum examination within some of the x-rays and some of the cases. Surveying by this procedure is less costly, less laborious, and more purposeful. Matched random sampling is a method of assigning participants to groups in which pairs of participants are first matched on some characteristic and then individually assigned randomly to groups. The procedure for matched random sampling can be briefed with various contexts. For example, two samples in which the members are clearly paired and are matched explicitly by the researcher. For example, IQ measurements or pairs of identical twins. Those samples in which the same attribute or variable is measured twice on each subset under different circumstances, commonly called repeated measures. Examples include the number of times a group of athletes for 1,500 meters before and after a week of special training, the milk yields of cows before and after being fed a particular diet, the reading scores of kids before and after an intervention, all those sorts of things. Quota sampling is the population is first segmented into mutually exclusive subgroups, just as in stratified sampling. Then judgment is used to select subjects or units from each segment based on a specified proportion. For example, an interviewer may be told to sample 200 females and 300 males between the age of 45 and 60. It is this second step which makes the technique one of non-probability sampling. In quota sampling, the selection of the sample is non-random. Convenient sampling, sometimes known as grab or opportunity sampling or accidental or haphazard sampling, a type of non-probability sampling which involves the sample being drawn from that part of the population which is close to hand, that is, readily available and convenient. This happens all the time in educational research. You have access to someone you know in a school, a class of students, etc. The researcher using such a sample cannot scientifically make generalizations about the total population from this sample because it would not be representative enough. This is a interesting depiction of someone yelling out of a building, trying to harass somebody coming by in order to get a convenient sample because it was just the closest person at hand. Judgment sampling or purposive sampling is when a researcher chooses the sample based on who they think would be appropriate for the study. Maybe they're the best teachers at a school, or the gifted learners, or the struggling readers. This is used primarily when there is a limited number of people that have expertise in the area being researched. Panel sampling, on the other hand, is a method of first selecting a group of participants through a random sampling method and then asking that group for the same information again several times over a period of time. Therefore, each participant is given the same survey or interview at 2 or more time points. Each period of data collection is called a wave. This sampling methodology is often chosen for large-scale or nationwide studies in order to gauge changes in the population with regard to any number of variables, from chronic illness to job stress to weekly food expenditures. Panel sampling can also be used to inform researchers about within-person health changes due to age, or help explain changes in continuous dependent variables such as spousal interaction. There have been several proposed methods of analyzing panel sample data, including growth curves. This concludes our discussion on sampling of probable samples as well as non-probable sampling plans, including sampling frames and the different types within each subset. I hope you've enjoyed this presentation, and I look forward to speaking with you.
Good morning.
Morning, Brother Shafiq.
Thank you very much. I hope the video was informative and most probably educative. In most cases, we do sampling and we might not get the various insights, and most of all, the questions that come from either supervisors or other the supervisors or other people who read our work may not be forthcoming, especially at the defense stage, where I've seen a number of us sometimes embarrassing ourselves to the extent that you are asked maybe what seems to be a simple question about your choice of sampling, and you may be a little problematic in answering that. And so many times we also end up confusing these terms, the sampling process, the sampling frame, and all that. I'm very sure that we have a number of people here who could share their insights in as far as the video is concerned. But I think let us first get learning points from which we got from the video. I would say that we can have a number of people who could give us what they learned from the video, especially from the different types of sampling that we have seen. Most especially if we have the chance to give insights based on the work that we are doing, that would be most beneficial. Can I have anyone who, let me look at the participant list to get someone, anyone who can give us what they've learned from there? I wouldn't want to. Yes, Emojong Ronald.
Yes, thank you so much. The first thing I've picked up, there are two types of sampling techniques used. There's probability and non-probability sampling techniques. But most importantly, as you select or you narrow down on one particular sampling technique, you have to understand how it is used, what are the advantages and disadvantages, but also most importantly, why have you chosen that particular sampling technique? How sufficient is it in regards to the problem you're trying to answer? And most importantly, does it support your philosophical approach? I submit, Chair.
Thank you, Ronald. That was a little short, but I think we get our point. I saw something about panel, and I thought Bernard B. Coming from economics, you would share a little more on that, because Professor has been talking about panel data. Is there any connection between the panel sample, the panel type of the panel subcategory of sampling and panel data? Bernard?
Yes, Shafiq, good morning, everyone, and thank you for this another video this morning for us to pick lessons and share experiences about. Picking on from where Ronald stopped, I think the bottom line is that we have two approaches to sampling. Probability, where you are giving a chance to every unit or whatever to be selected, and then probability approaches that involve subjectivity in a way, but of course justified why you are going for this group and not this unit. If you are assessing children, maybe that would be the reason why you should exclude the adult population, or if the intervention is targeting the elderly, it will be a reason why you are maybe leaving out the ones that do not fall in that group or whatever. I think that is what I also wanted to start with for as a lesson that I picked from the video. Now, to your question, Shafiq, about panel sampling method, exactly mirrors the requirements for panel data selections, not necessarily related to panel data econometrics or analysis, but the approach in a way. And so in simple terms, like the video mentioned, you randomly choose a group of people or units, in this case, to be part of a panel that takes part in a study several times over a period of time. So you pick this group, just like we also make panels, you go and observe that unit several repetitively or several times over a given period of time, because you want to track continuity, because you want to go beyond the cross-sectional or a one-off observation. Usually you want to understand this dimension more than just going at once and you observe. So you'll go back to these same people or same units repetitively, just because you want to observe those, for whatever reason, observe those units over time. And that's where the wide panel comes in. So the chance of repeating or observing that person is strictly 100%. The first time you observe that group, you go back to that group, you go back to that group, depending on the given time you are supposed to do that. And that's where the name comes from. of course, which exactly mirrors how panel data approaches our analysis and also estimation is follow the same kind of action. The justification usually is not you want to build a story about that unit or person or whatever you're observing over time, so that you don't only make inferences based on the one-off, so to say, that you went there, but because you want to gain that continuity. Shafiq, I think that's what I can mention for now about that. Yeah.
Thank you, Bernard, for that. It's always an interesting thing to talk about panel data, and now to talk about this sampling procedure, which is connected to that, so that you can get a story. What I love about it is that you get insights about the population or the sample over a longer period of time than a one-off. Now let us talk. I think I will drive this this session, because it seems, especially when we come to sampling, you don't have a lot of feedback and response, because I think most people take it to be something from statistics, where you know where the complications are many. But let us talk about representation, because at the end of the day, sampling is about representing a population, and most probably giving inferences about the population. And I think what I notice is that we are overly defending representation, other than should representation of a sample to the population be obvious, or it is something that we have to defend all the time. I see most of us as students, I don't know whether my question really makes sense. We tend to defend what we think, how we feel about our choice of sample or sampling procedure is, other than the question would be, why isn't it obvious after choosing this sample, and why do we really have to defend whether it is representative enough or not representative? I think I will let one of the seniors to talk about this. Dr. Nkurunziza is always a person that I always go to when issues of representation, representativeness of a sample come in. Dr. Nkurunziza, would you want to throw light on that?
Thank you, Shafiq. Good morning, everyone.
Good morning.
The essence of coming up with the appropriate approach to use, the major focus actually is on representation. Now, given the presentation, we see that there are two major approaches. We have the random or probability or statistical approach that we use. And you have seen in that case, there are a number of aspects you have to look for. One is that you are dealing with a known population, meaning that you can easily have a sampling frame when you're using the random sampling or probability sampling techniques. You are dealing with a known population, meaning that the selected individuals you can even estimate the probabilities of each sample that you derive. So in that case, once you are dealing with known population, then it is much easier to get representativeness. In other words, to get a representative sample. But of course, we have seen that there are a number of techniques under each. Now, I think that is the major point we need to pick, that we are choosing from known population, and you can attach probability to the samples that you have derived. And of course, that has implication in your methodology, that if you are mainly trying to look at generalization, you want to generalize, then it is important that you really, based on those random sampling techniques, the appropriate one. And the other one, of course, that has also implication on your research design. That yes, does your research design require you to use a representative sample, which you can obtain using the random sampling? That is very, very important. Then there are cases where we find that it's very hard to get a known population. Now that is when you now think of the non-random sampling techniques. You are choosing from unknown population, meaning that it's not easy to have a sampling frame. And that is where now you base on the individual subjectivity. In other words, you base on subjective argument, based on your knowledge as a researcher, that it's not by chance that individuals will be selected, but there are certain factors you have to consider. And that means that's when now you try to use those factors to also to reach a level of representativeness. Now that also has implication on research design. If you wanted to generalize and use the non-random sampling, that's not clear, because you don't have representative sample. You try to get representative, but you realize that generalization is actually a bit limited in that case. In most cases, when you are looking at case study methodology, it's important that you think of those non-random sampling techniques. Now, the other thing maybe I would like also to add, in sampling, you need to understand your unit of analysis and unit of inquiry. If you are looking at unit of analysis being organization, then you think of how you're going to sample the organizations. If you are looking at it, the unit of inquiry at the same time, you also need to define how you're going to select the individuals. So, which means if your unit of analysis is organization and you want to aggregate the data to the unit of analysis and you want to generalize, please think of the random sampling techniques. Otherwise, if you don't plan very well, you reach a certain level when you are testing for those parametric assumptions. And by the time you are testing for parametric assumptions, somebody questions, but do you expect your data to fit, to really meet those assumptions if you use the non-random sampling technique? So please, as we talk about the parametric and non-parametric assumptions, you must have thought about representativeness of the sample, how you selected your sample, those techniques you used. That's very important. The other one maybe I would also want to mention is that when you have you are using the random sampling techniques, we expect, of course, to have some bit of sampling errors. they're expected. But also don't forget the non-sampling errors as well. Now the sampling errors may come in because you have failed to get a right sample size. Your sampling frame is a problem. The sample technique you have chosen may not be really appropriate. So expect to have those issues and how to handle them. There are also non-sampling errors, which I know you can get as well, especially when you have designed a questionnaire and the respondents are not able to answer. So you end up having non-response errors. Shafiq, allow me to stop here. Hello?
Thanks, Dr. Nkurunziza. It's always very interesting to listen to you when it comes to statistical issues and research methodological issues. Dr. Nkurunziza helps out so much on both bachelor's and postgraduate teaching on the research skills. That's why he has a big insight in that. Like I said, this is a topic many of us don't really want to talk about. I will just throw out another question there, and I hope that someone can come in on this. Most probably, as we do our research as students, we also tend to think that there is some kind of superiority that probability sampling methods have over non-probability sampling methods. And I don't know if there is anyone who can throw light on this. We always think that the probability sampling methods may be superior, and maybe when we use them, we will come up with a better representation of the population than the others. I don't know, maybe a supervisor or a senior colleague would be able to answer this. As that comes in, I just hope that the students on this platform are really into this. Evelyn Kabongera, George, Gideon, Joseph Elasu, can someone come in before a senior colleague comes into that question, just to give us insights on what you learned and what your comments. Joseph Elasu, are you there? Okay. I would need Dr. Gideon, would you, that is something I would really love that you, yes, Joseph, come in.
Yeah, thank you very much, Shafiq. Well, the question you have put out this morning is very pertinent. Of course, there is a tendency that we could easily be thinking towards that direction, that probabilistic sampling techniques could be more superior. Well, but I think this kind of thinking comes from the way in which we handle probabilistic sampling techniques. I think they're based on some criteria, some mathematical, criteria that helps one to, it's easy for you to convince people that I followed this procedure and I ended up with this sample. But when we talk about the non-probabilistic techniques where it's subjective, it's based on your judgment, sometimes I think people find it very difficult to explain that really I use this purposive sampling, and this for sure, this would be the right sample for me to have. So I think the issue is the criteria. One side, you really have some mathematical, procedure that helps you to, it becomes very easy to defend than telling people that, you see, I just use some form of judgment. I thought these guys say that maybe this category of people, because they're in particular positions in the probably where I'm going to take my research, I think they have the kind of information I want. Well, that is subjective. That is up to you. That's what you think, but it becomes a little bit difficult to convince people. But my take is that I don't think one is more superior than the other, but I think the procedures are the ones that are making us think that the other is an option to go for than non-probabilistic. That's the little I can probably say this morning, my brother Shafik.
Thank you very much. That is a very great insight in as far as the question is concerned. It always reminds me the story about the choice to use a quantitative approach rather than a qualitative approach. In the last 10 minutes, I would give this to supervisors, to give us insights, because like I said, as students, we are always very skeptical about our choice of sampling methods and all that. And I think the question will still come in, that we always have that problem, and or thinking that probability sampling is much superior. And like Joseph put it, it's always hard to defend the fact that someone has used non-probability sampling methods like convenience sampling. I would ask any senior colleagues to give us two senior colleagues maybe to give us some closing remarks and what they've experienced with us, the students, in as far as choosing sampling methods, choosing one sampling method in comparison to not choosing another one. I don't know, Professor Laura, do you want to throw a little light on that, and then we will end with Dr. Michael Okoche? Or Dr. Michael Okoche can come in first.
Okay, thank you so much, Shafik, for the opportunity. I think Elasso has largely said the issue. The truth about all these techniques, depending on the methodology, which draw from the philosophy, with the interpretives, which are very subjective in nature, which the sample must be of quality, looks at quality. You find that non-probability sampling techniques are more appropriate. But quantitative studies, which are about quantity, which of course from the positivists, because the positivist orientation follows most times the methodology is called quantitative, or the methodological assumptions now will be quantitative, and then anxiological assumptions, which basically define the ethical considerations, will normally be aligned towards quantities. So quantities will be justifiable. So really, for you to for you to do a quantitative study using an non-probability sample. And I think that's where the major problem is. Sometimes even it's not just about whether which one is superior, but sometimes we find that most times people just use them anyhow. You'll find somebody doing a quantitative study and is purposively sampling, but normally when you are dealing with positivist or quantitative studies, the most appropriate sampling techniques, and even when you look at the different sampling techniques within probability sampling, some are more significant in a particular situation. So there are instances where you use stratified, there are instances you use simple, there are instances you use multi-stage, and many others. So it is very imperative that even when you are talking about probability sampling technique, you try as much as possible to ensure that the characteristics of the population are critically are captured. So I think the within probability and non-probability, probability should critically be used on positive studies, which basically the sample, the sampling depends on the quantity. So, but these qualitative studies, which basically is about, like if we are talking about maybe purposive, we purposively sample someone. And of course, when I talk about the interpretive paradigm, the interpretive basically believes that there are multiple realities. So when we look at the population, which realities are we likely going to face? Or which realities are the people whom we are going to interview have? In instances where you have a particular population, and you really see that there are likely maybe 2 or 3 realities. You might find that the managers at the headquarters have a different reality of what is still taking place about business. And then you find maybe now the customer who is buying at another country has a different reality. So you purposively sample those people. So you find that that will be much more better, other than you just basically conducting a simple, I mean, a non-probability sampling technique. Now, let us talk about instances like if you are dealing with the polarized populations. Let us talk about politics, opposition, government, and then you basically simple random sample. If you get the people of particular orientation, you get answers which are basically skewed to a particular side. So you'll find that depending on whom you simply random sample, the results will be different. So, but if you do a stratified sample, you get a more representative. So I think it is very important that we understand, first of all, the orientation of non-probability sampling techniques, that they are mostly oriented to qualitative studies, and then the probability sampling techniques, they are more aligned to quantitative studies. But also, of course, sometimes you find people debating, but that's the reality about it, because it comes from the one saying there's one reality and the other one saying that there are multiple realities, which is become really from the philosophical orientation of different studies. So again, especially for students of philosophy, those are things which you'll be judged against, because they look at that's why you must be able, and sometimes I've had some of the senior colleagues challenging the students that, now, why are you using this? But of course, they are trying, in view of the philosophy, really, have you looked at this? Have you sampled properly? Have you captured all the multiple realities? If you are talking about a study, like, and I think it begins from philosophical orientation of your study, which must be aligned properly with the phenomena you're examining, and then now you go into the sample. But it will be erroneous for you just say that this one is superior than the other in different instances, depending on the circumstances. I think, Shafiq, that's what I could do. Just say thank you.
Thank you, Dr. Michael Koche. I'm very happy. I think I asked that question and it was personal, and I think I got the best out of it, and I'm very sure many other students did. My last question, which I got from my inbox here, and which is a little related to that, and we might not answer it. I don't know whether anyone could attempt. Is the probability, or is the probability that using two approaches in one study, that is using a probability sampling technique and a non-probability sampling technique in one study, could even have any chance of being justifiable at one point in time? I don't know anyone who could take over that, the senior colleagues. It's something I've not thought about, combining techniques from two different, from probability sampling and non-probability sampling. I don't know whether I could throw that back to Dr. Nkurunziza in just 1 minute. Is there any chance that that would be justifiable?
Okay, thank you, Shafiq. Yeah, it is possible. As I mentioned, we in every study, it is important to understand the unit of analysis and unit of inquiry. Now, there are some studies that where you are looking at, for example, financial performance of an organization, or I mean of organizations. Now, you realize that if you are looking at financial performance of organizations, you need to have the population, which is the population, which is the number, which looks at the organizations. And then you also need to know within these organizations, who are the people to answer, for example, your questionnaire. Now, how will you select them? Now, you find that for organizations, if you are interested to really generalize, then you will have the random sampling technique at the unit of analysis, which is organization. And then you may think of maybe a non-random sampling to select the respondents for the unit of inquiry. Now, that one is possible. So you can use, for example, passive when you are selecting the respondents to answer your questionnaire. But when it comes to the organizations, which is the unit of analysis, you use the random sampling, one of them that is appropriate. So it is possible. Then the other one, of course, the other justification is that some studies we intend to translate the data sources. So in translation, you can translate, of course, based also on the way you are sampling them. I submit.
Okay.
Shafiq.
Okay, thank you very much. I don't think there is any topic in as far as research is concerned that could be, exhaustively discussed. And this morning we are very happy that at least we have had a chance to talk about something which every one of us as students will have to deal with at their defense at one point in time, not just at the PhD, but any research conference or any research endeavor. Sampling procedures is one of those things that everyone will always have to defend when it comes to any research endeavor. I thank everyone who has contributed to this video today, and I hope that every student got something out of it.
Yes, Shafiq, are you still there?
Sorry about that. I had muted myself while I was still going on. But thank you, Professor, for this initiative. Thanks for everyone who has given us some insights on sampling. And I right now hand it over to Dr. Michael Koch. I think today we are having a presentation from one of our own, Wabukala Bernard. Over to you, Dr. Michael Koch.
Yeah, thank you so much, Shafiq, for this morning session. I think to me, I really hold it as a very good session because one, it helps the students to demonstrate what they know, but also it helps that there's what some people call cross-fertilization, when colleagues learn from each other. And also we learn from it. Me personally, I really appreciate the morning session. Thank you so much, Shafiq, for ably sharing that session. I want, before we start moving forward, I want by acknowledging all of us for having been able to wake up so early this morning. And I must appreciate you. It's not easy to wake up early, despite the errands we have through the week. I want also to appreciate our senior mentor, Professor Joseph Ntai. We really appreciate you and we thank you so much for the initiative and also consistently being there for us. This platform has helped so many people, as senior colleagues, as students, to grow. I also want to appreciate our senior, our mentors, Professor Laura Orobia. Really one of the pillars of this platform, Professor James Kagari. Great appreciation. I also want to appreciate the senior colleagues, Dr. Ronet Atkunda, Dr. Gideon Nkruzinza. I'm always excited when you are making your submissions. They come with a lot of insights. Dr. Goretti Sheone, in case I've not seen others, but I must appreciate you. Now, I also want to acknowledge that this platform draws people from different countries, people from different universities within Uganda, Makerere University Business School, Utamu, Uganda Management Institute, Uganda Matters, Busitema University. I think Busitema is having a first cohort of their PhD, and I think they began joining from the last Sunday. So I must thank all of you, and I'll keep on acknowledging all of us. So far we have seen the benefits where people ably attended the sessions, and then they learned from the discussions, they participated in the students forum, and then based on that, they present their proposals, and then after presenting their proposals in this platform, they go ahead and defend them. So I think we're continuing to see that. And for the series of the weeks, we have had different people presenting. So this week, we are having Bernard, and we want to give Bernard the opportunity to share his presentation. Then based on his presentation, we give comments. And of course, the One of the students actually told me that sometimes, and I think even we saw, I think last week we saw very substantial comment being given by students, which is really a good demonstration that we are learning. So, like Professor has posted, we have somebody from Nepal. He has consistently attended from, I think last year, that's when he joined, last year, towards the beginning. Yeah, so Zimbabwe, Kenya, Nigeria, even Cameroon. I remember one alumni, somebody from Cameroon called Tanzania. Yes, Bernard, I want to take this opportunity to welcome you and take us through your presentation. Over to you, Bernard.
Thank you, Dr. Okoche. Good morning, professors, doctors, and fellow students on this call. Dr. Okoche, for reference, kindly, how long or how many minutes are you giving me?
Okay, you take 40 minutes, then we can.
Okay. All right. Thank you very much. Okay, friends, professors and doctors, Bernard Wawukala is my name. I am a PhD student in energy economics and governance. This morning, I am delighted to share with you my journey so far. I have reached at this level and developed my proposal. So I'm here to tap into your guidance, tap into your suggestions as I move this journey forward. So my area of my research idea is electricity security, what we would call a criterion variable. And in this, I'm looking at energy dynamics that is related to electricity security. The energy dynamics we are looking at energy sector forces that could stimulate, that could promote, or could even constrain my dependent variable or criterion variable here in this case, electricity security. I'll follow this as a guide in terms of what I'm going to share with you this morning, background to the problem, theory right through, and then I'll conclude with the proposed methodology that I have. Now, maybe a preamble to this, the Oxford English Dictionary defines security as protection from harm, protection from danger or attacks. Now, in the context of energy, issues of security started in early 1970s, the Cold War between the Soviet Union and the USA after a trade embargo by the Arab League that led to crises in oil supply, and countries that were dependent on imports of these oils suffered supply disruptions and also affected the economic activities given the role of energy in the economic space. I have to mention it is at this same time, or because of this crisis, that gave birth to the institution we refer to today as the International Energy Agency. And that's where security issues start from in the energy space that we are looking at today. So by definition, we are adopting or am using this definition of security by this institution, which we could loosely say they are the custodians of energy security today as we speak. So electricity security, electricity is just a form of energy itself. So referring to the sustained availability of electricity at an affordable and reasonable prices. What I make from this today in reference to this definition is each of us here today at your home or at your place of work or any other position that you are. So today, if you, for any reason, if you want to use electricity for any particular activity, but it is not there because it is off, or because it is there but you cannot access it, or it is there but you cannot actually afford that electricity, we could loosely classify you or define you as being electricity insecure. And that's what I want to bring the context going forward. That is how we are defining or using this particular concept here. So what we learn, of course, from this definition is whatever the cause or reason may be, what you define or what you classifies you as being secure or insecure according to this is one, there must be something of value or something supposed assumed by society of being valuable to the society or to the individual that warrants protection from whatever attacks or threats that we are making mention of. So to this study, we are not, the claim here is, the knowledge claim here is that neither electricity nor security is new. Because electricity, for instance, goes back to the second industrial revolution times, that is 1870 up to the 1930s, which was punctuated by increase in manufacturing of steel and iron, which demanded or required heavy energy to make those manufacturing outputs, which was actually called factory electrification at that time. We are still doing that today. We are still producing steel and iron using electricity. On the other hand, security itself dates back way to the 16th century, which is largely accorded to the Egyptians who started the whole issue about security using wooden boxes to protect or to keep their valuables at that time. They were later on joined by the ancient Romans, who came up with a more durable security system in the name of locks as well, the current or the systems of padlocks and keys, again, in the name of securing things they thought were valuable at that time. And in fact, today, these codes that you are using on your smartphones or computers or whatever are still credited to their system of security. So these are not electricity or security. We are not saying these are new things. Rather, our claim and potentially where we are likely to make a contribution here is that security, electricity security is an evolving phenomenon, highly contextual, especially when you factor in time, regional differences, as well as energy resource horizons. Across time, for instance, you are saying in Uganda, the electricity we have today is not what we can go and observe right now and say we are secure. It has relationships with what we used to have from time back. For instance, today we generate electricity from so many sources, but in 1964, it was only from one hydropower plant at that time, which we had. So over time, it has changed its face in terms of how we produce it and even how we use it. Spatial differences here or regional differences here, I'm talking about, for instance, comparing Uganda and Japan in two different localities. What constitutes electricity security in Japan, though comparable, may not exactly be transferable to the situation or circumstances down here in Uganda. And the final on energy resource horizons, we need energy resources to produce this electricity. And so these differences across resource endowments, there are countries that are heavily or completely dependent on fossils for electricity generation, while there are countries like Uganda that are dependent on so many sources of energy for electricity production. So these differences continue to bring that kind of evolving approaches to look at it, which we think, which I think is this study is proposing to make a contribution at for this particular cause. But from the global perspective, today as we speak, a demand for energy is increasing, but importantly, it is shifting to what we call electrical energy or electricity for production, for industrial activities, for household use, including transport. In fact, the International Energy Agency projects that by 2050, 40% of global energy demand is going to be from electricity use alone. And that's why the study is speaking on electricity as part of the analytical lens for us to put emphasis on. Two, in the global development agenda today, we are pushing for access to clean energy. We are pushing for reductions in emissions, on environmental quality concerns. And so electricity security actually forms what we call now today as the energy trilemma. An economy which is going to grow green growth with available and accessible energy resources, but also must be done in an environmentally friendly manner. And away from that, in scale down to society or country level perspectives, empirical studies have demonstrated and continue to demonstrate the relevancy or the contribution of electricity to economic development through creation of jobs. Families or households or people are using electricity for businesses as productive use to create jobs and employment. Countries are relying on electricity for industrialization, but electricity also leads to improvement in quality of life, from lighting, from cooking, to even using electricity to, interact with the technologies that we have today. And on my last issue, extending my background, why I am pushing for this particular constructs really is because scaling down to electricity per se, there are issues regarding electricity that are evolving, as I mentioned, or what forms or shapes electricity today, including its reliability and costs. Now, prices or affordability issues, as well as fees for new connections, things that matter most for electricity sector emissions remain under investigated from some studies which directly or indirectly have implications on what we are defining to this morning as electricity security. But finally, from reviewing literature and in terms of identifying what is there today or what is concerning and driving us, as a concept, existing studies are dominantly articulating and discussing measurement issues. In other words, approaches. How do we go ahead and tell that country A or community A or family A is electricity secure? And two, most studies that are done so far since the 1970s, where I started from, have largely focused on energy security, and energy security is quite broad. There is electricity and other issues beyond electricity, or have used a single fuel, largely oil, which gave birth to this whole concept of energy security. And as we know, oil as a resource is still very predominantly traded. across communities. So from that background, what am I observing in Uganda today that would say there's a problem around this particular issue? The National Energy Policy, the 2019, which was revised, of course, outlines issues that are really pressing our energy sector in general, among which mentions the constrained economic development that we see or have today because of inadequate energy sector investments. These are capacity issues, could be reliability issues, the energy demand that we need today to move us as a country from what we are today to the next stage. But individually or in terms of perspective here, we have capacity of electricity in this country, currently about 1,380 megawatts. But the issue here is where you're calling it low, because aspiration is in our long-term and medium-term targets. This amount is way below the 41,000 megawatts that we need, for instance, to propel ourselves to the middle-income country status. At the same time, low electricity per capita consumption, in other words, Ugandans on average annually use 450 kilowatt hours of electricity. But our middle income status drive requires that at least on average, Ugandan should be using around 3,600 kilowatt hours in terms of consumption and capacity. But also issues to do with access to electricity itself. We are a country that are still very low in terms of electricity access, just averaging about 42% as we speak today. In other words, about 4 out of every 10 Ugandans today as we speak have access to electricity. To the issues, dynamics around the electricity in Uganda themselves, we are always consistently having power outages or what we would call blackouts, blamed on a number of issues, some of which could be technical, others are natural issues, could be social profilings that we want to look through. But to make a contribution here is my empirical assessment on the influence of these threats on electricity security, particularly, remain uninvestigated for Uganda. So what am I seeing, or from what I'm trying to make a contribution to? There are 3 gaps here, so to say. On the practical side, what I've just concluded with on the previous slide is issues of electricity access in Uganda. Having available energy resources, including electricity itself, does not translate into access. We are still a country comparably in sub-Saharan Africa with the lowest access rate. But even this access itself, the 42%, if we interrogate it, is also obscure. Is access about having a power line into your house, or actually pressing a switch and making sure electricity is on? What about the outages themselves that we are seeing today? I think we are one of the countries in the region with the highest number of outages. Some of them are short as in minutes, others go on for days. In some places could even take weeks, again, on issues that we see today. As a concept from the review, electricity security is really a multidimensional concept. You cannot almost isolate one thing to explain or understand electricity security. It comes in so many dimensions, to the extent that pinning one dimension down without looking on the other side provides incomplete assessment of what would be today. And it continues to produce controversy in literature in terms of what should constitute electricity security today. These 2 studies are the ones that have closely come to try to assess and measure it in terms of the metrics that they have put across. And lastly is on the methodological space. There are inconclusive debates regarding how to measure electricity security up to now. It is still an ongoing debate. And majorly here, for instance, aggregated indicators or dimensions better than non-aggregated indicators in terms of what we should use or do today for electricity security. The aggregated indicators have been largely preferred at the macro level space because they provide assessment in terms of policy interventions, but they are also criticized for concealing information when it comes to the impact related assessments to communities and societies. The non-aggregated indicators, on the other hand, while being pushed for at micro level analysis, also fall short in terms of trying to explain these phenomena or electricity security because they tend to pick on isolated number of items in the assessment of electricity security. And this is where I'm coming from to see what contribution to make for this particular cause. So the purpose, main purpose for me, so to this study is examining this concept and its dynamics, which I call the energy dynamics or correlates or factors in Uganda, by looking at 4 specific activities or objectives here. Number 1 is to assess barriers to electricity security. The reason I'm starting from here is you cannot, from assessments done so far, start describing security without knowing what actually threatens it. In other words, there is no need for you to go ahead and even talk about security without knowing contextual or whatever factors that exist as threats, as attacks, as dangers to what you claim to have, in this particular case, electricity. Now, the second activity or objective that I'm going to do after that is to try to characterize electricity security for Uganda. And I'm going to attempt to construct an index. This index is a metric that should try to explain or characterize or define what electricity security in Uganda is, to even for reasons of trying to say, okay, is Uganda secure or insecure in terms of electricity? But importantly, for that reason, an index which we don't have on this particular concept today would help policy makers and even investors on the choice or decision of investments regarding the overall electricity sector in Uganda. So derived from 2, number 3 is to try to analyze or understand these correlates or the dynamics. What explains electricity security in Uganda that could be used for intervention or analysis? And then finally, to try to borrow from our strategic plan, the electricity sector, one of the issues is to try to increase capacity of electricity in Uganda, both in terms of access, which is transmission and distribution, but also supply itself, because the population is growing and the economic growth drive means we need more and more supply of electricity. The theory behind what I'm trying to construct or explain here in this study is what we call the securitization theory. It is born in the disciplines of international relations, based on early works by Ole Weaver. This is early 1980s on securitization and desecuritization. But And this theory, so, is up to today is a debate between what we would call two parties. One party is what we call the narrowers from the word narrow, who confine themselves to security on only political and military interactions of the state. To them, security is about protecting the state or the country in this case, alongside military and political profilings. However, the other party is what we call the wideners from the word wide, who have extended security analysis and conceptualization down to beyond political and military requirements. Because to them, security, to the wideners, security actually does not affect the state or country per se, but actually affects individuals, affects persons, affects societies. And that's why it has been extended to even non-military and political requirements to understand security for this particular case. And so this study is adopting the definition by the wideners, because then this goes beyond military and political horizons to even other sectors in the economy, because security to them is a concern of impacts of whatever it is to society and the communities. But basically, the main aim or premise of this theory is that security is a speech act. The power of semantics and language, that by labeling something as a security threat, today if you say this tree is a security threat, that pronouncement alone and utterance alone can actually turn that particular statement or item into a threat, and it becomes one. That is the fundamental labeling behind this, which means by requirement, things, a threat can be existent, can be induced, or can be both. But the wideners in support and extending this theory argue that semantics and linguistics are only a minimum requirements for this particular theory. And in fact, threats don't need to be uttered per se, because there are things that are existing that we have that affect human beings and societal well-being at that time. But the most important thing, and why we are using this theory in this study, is because analyzing security starts by asking three questions. One is security for whom? Two is security from what? And then three, security for whom? Security for what? So the three questions, those three questions imply one. This theory only applies by us answering those questions. One, there must be something which appears to be threatened and needs protection, which they call a referent object. In our study, it is electricity. Two, their security from what? It means there must be some threats or danger, either existing or induced or both, that need to be tackled, to that require security measures to come up. And then three, someone or an agent who should provide that security to whatever who administers or produces that security, so that along that continuum is finished. And indeed, energy studies as well and the electricity assessment as well also use these same questions to assess or to try to understand security in the energy sector. The weakness of this theory, though, is its emphasis on speech act and also requiring what they call extraordinary measures to counter the threats. However, the wideners in its support have said threats are not necessarily about acts or linguistics. Threats go beyond just talking. There are some things that we can observe that affect individuals, and And the measures don't have to be extraordinary. Even ordinary measures as well can be used to avert, for as long as they don't change the structure of policy change or interventions that you may bring. And so based on these, the strengths that the wideners bring in the application of the theory, manifestations of security extends beyond the political and military horizons. Issues that threaten security of anything could be natural, including energy and electricity, technical, environmental, and the social factors. So based on this theory, as well as the assessments from literature, I am conceptualizing this issue in a three-part kind of process. On the left-hand side is my criterion variable, dependent variable, and which we are calling electricity security, that has been conceptualized from literature into so many dimensions, which are 5. System stability, accessibility, economic impact of electricity prices. You must have a sustainable electricity generation, as well as quality of governance, which I will expound in the methodology itself. The second part is the electricity security, the autoregressive behavior, that the electricity we have, the security we talk about today has a bearing on past behavior or periods before today, what we can use or observe or claim to be today. So the past resources, the past electricity sources, the past impacts of prices and accessibility today that measure electricity security have a bearing on what we claim or to call electricity today. And that's what we mean by being autoregressive. And then the dynamics, those forces that I said could promote, could stimulate, or even constrain electricity security is a host of factors or variables on the right-hand side that I've listed below based on the review of literature from this particular course. Still very early though, but potentially this study is likely to contribute in 2 or 3 ways as presented here. First, extending the application of securitization theory on theoretical grounds beyond the military and political to now the energy sector or energy space, and to be specific, electricity sector. 2 is our focus on emphasis on electricity security, isolating it from the broader issue of energy, because energy goes beyond electricity. Electricity is just one version of energy. But importantly, our attempt to characterize to even electricity security in Uganda, so that we could also be labeled among other countries in comparative terms if we are secure or not in terms of electricity. And then, of course, to try to unbundle the context-specific variables that align with Uganda as far as electricity security is concerned. Now, the methodology, finally, as I close this, as terms of the process or the steps that I'm planning to go through this. The philosophy is positivism, and I draw this from the works of Karl Popper in his works, Conjectures and Refutations. The background here is that reality exists, which means it is structured, it is objective, and independent of the experimenter or the investigator. But Popper, in his extension of the beliefs of positivism, without dismissing them, argues that this reality, however, can only be known probabilistically, because there is still an influence of human impact or conjecture in terms of what we can claim to call reality. So, and that's why we are calling for positivism. So beyond reality being subjective and can be verifiable using scientific approaches, there is its occurrence and appearance is still hinges on probable appearance. In terms of phenomenology or epistemology or the knowledge creation process here, this study will follow a deductive or explanatory testing approach. And the theory behind here is, though truth could be objective, which is knowledge here, knowledge is not necessarily based on a priori assessment as positivists claim. It depends on also human influences. In other words, this, while you can make very good deductive and explanatory conclusions or inferences from data to test or to generate this knowledge, it is still subject to human influence, meaning that this knowledge which is produced through this approach can still be modified, can still be changed, or can even be dismissed based on what the findings are saying, or especially if the data and circumstances and contexts change. And that's what we are deriving, as an approach for knowledge generation here. Now, the design is quantitative in nature and specifically quasi-experimental quantitative. Now, quantitative approaches are on some kind of continuum. The quantitative approaches can be descriptive, can be correlational, can be quasi-experimental, which we are picking, or actually experimental. The central issue behind quasi-experimental quantitative approach or designs is that the independent variable can be identified, but it cannot be modified by the experimenter or the researcher. On the other hand, the dependent variable, the criterion variable, can be modified by the researcher. And then the impact of independent variable on the dependent variable can actually be measured as output. So objective number one, how am I planning to go around this? A systematic literature review, because it is the first stage of trying to understand electricity security before we even go ahead to characterize it. What are those barriers? What are those threats? So a review of empirical works that define, measure, and construct electricity security. I will follow the exclusion criteria based on the objective or keywords in the objective function here, which are barriers to entry. And then once I've assembled that, I will review and put together the relevant energy reports, the studies, to try to come up with conclusions as the major, looking for the similarities or differences in terms of what would say are barriers to electricity security in Uganda today. For the second objective, I'm going to construct an index, as I earlier mentioned, and this approach relies on statistical and mathematical processes to try to understand or to construct a measure or metric for any phenomenon that you want to do. So it is simply a series of steps. We start by identifying and selecting indicators from literature and theoretical findings that try to explain electricity security. Well, the second step is to do some kind of discrimination analysis. Here you are talking about this assemblance of all the indicators. You're trying to see which indicators serve the same purpose so that you can reduce them for analysis without making them repetitive. The third step is to just a test of reliability that the indicators you have selected actually measure what you are claiming to measure. Then 4 is the standardization, or what statisticians call normalization, because all these indicators don't come in the same measure or units. Others might be in monetary terms, others might be in other units which require this. And then you'll attach weights for those that you have finally standardized by trying to define or add relevance where possible for the indicators you are using. And then the last step is to try to aggregate these weighted indices so that you come up with this metric or measure. Now, for reference, not every phenomenon, not every index follows religiously all these steps. It depends on what you are constructing. It depends on the data availability, things which will be reviewed and presented according to that case. But for our study, or for this study, finally the energy security index will be summing the weighted indices from the above steps. Using from 1 to 5 because I have 5 dimensions that may have sub indices, of course, but that is what it would be. And this indicator will be the weight summing between 0 and 1, and as well for the period which data permitting between 1980 and 2020. So in the interpretation here is a score ranges between 0 and 100, 0 being weak performance, and then 100 will take you to best performance for that particular country. This is objective number 2 in terms of the indicators or dimensions that I've just been talking at. The first dimension is system stability that you want to check with the available system. With stability or system reliability, we are talking about the capacity of an electricity system in 3 ways. 1, the capacity for an electricity to generate enough electricity to meet peak load. Peak load is that time when everyone is switching on gadgets and increasing demand for electricity. 2, the second one under system reliability stability is the ability to generate enough electricity for the whole year without load shedding issues. And then 3, testing the transmission and the distribution infrastructure. Now, the indicator here is power outages. Should any of those 3 items have an issue, we are likely to see power blackouts or outages. And we are talking as a measure, it is just number of blackouts and load shedding wherever they exist. So we are saying smaller number is better because a smaller number of outages would mean that the other 3 issues I mentioned are very strong, meaning adequate power, meaning transmission and distribution is strong, and therefore would give us a better structure. The second one is electricity access. Electricity security starts with also accessing it. Availability is not sufficient. So we use electrification rate here as an indicator. There are 2 ways of measuring electricity access: the national electrification rate or the household electrification rate. The choice between whether you're using household or national electrification rate is actually the data availability issue. In Uganda, though, we report electrification rate at the household definition by Uganda Bureau of Statistics. So anyway, the higher the percentage here, the better, or will mean that the country has invested more on, it's a signal of investments in the electricity sector, but for us, more people accessing electricity, so we would say this country or region is more secure. Third dimension is economic impact, which is associated with the prices. Now, prices have impact on 2 areas. One, on supply side, and the other one on the demand side. High prices on the demand side may discourage actually electricity security because people will either shift away from electricity for demand reasons. But on the supply side, it would encourage them. The balance here is with the type of prices to use, commercial, households, or what? We shall use industrial prices in this case, because industrial demand for power is more than a demand for domestic and residential levels. The reason is it is cheaper for transmitters and distributors to transport bulk electricity in the economic sense to these people, to sectors which use more. So the smaller is better, because then it would encourage mass consumption of electricity, and for us that will be secure. The third dimension is sustainable development of the electricity sector, and here we look at how profitable the generation system is. And this is the ratio of profitable generation to total generation. Bigger is better, meaning more generation or cheaper generation is likely to increase, availability of electricity, and therefore electricity security. And finally, quality of governance, regulatory governance, effectiveness, and control for corruption. These combined bring us to what we call governance quality. In particular, governance here is an assurance for investors, and also protection of what we have as an electricity system from maybe theft or vandalism if it is strong. So the higher the score here, most likely improvement in electricity secure index, and that's why we are going for that. The third objective is an econometric analysis, or trying to establish the cause-effect relationships for this particular assessment. We are using time series regression analysis, particularly the autoregressive distributed lag model, for assessing this particular objective. Why, which I'll mention later, because this approach, as conceptualized in earlier, I say electricity security has some autoregressive behavior. That the security we are talking about today has a bearing on what happens on past behavior in terms of numbers or what we associate with this particular cause. But importantly, this approach is selected for three reasons. One, it is after testing before you run, that your variables that you are going to use must be integrated of different orders. I'll specify that in the requirements, which I'm coming down below. But two, this approach has been seen to produce more efficient and reliable estimates, especially in cases where samples are relatively smaller compared to the other approaches. And they also provides long-run estimates which are reliable, meaning that we can rely on its estimates once you fulfill the conditions for policy and intervention in terms of an estimate. These are the variables or the dynamics that I was referring to, which are going to be modeled according to these definitions. The term ECT is an error correction term. This approach provides both short-run and long-run estimations of this analysis if the conditions from the tests you do actually make this position. Now, for which variables and where I'm picking them and how I'm measuring them, this is where the model is, and these are the variables, and this is where I'm going to collect the data. These are the hypotheses for each of the independent variables. The dependent variable I forgot to mention is going to be the index that was constructed in objective number 2. And then these are the independent variables that are associated to move with this approach. But generally, for a few of these as a demonstration, world oil prices, annual average price of crude oil. We produce electricity also. We have co-generators in Uganda who rely on diesel and and the petroleum products to generate electricity. So in this case, we have prices of crude oil going up directly have impacts on those generators who use this particular product. So they are likely to reduce or have a negative impact on electricity security if prices go up. Imports, we can't predetermine. Imports sometimes may increase electricity security, but may also reduce electricity depending on which wave it has. So theoretically, we cannot predetermine what direction this would take. For exports, the hypothesis here is an increase in electricity exports. Other factors constant would reduce electricity back at home. And that's why we have a decrease. But this is, of course, hypothetical starting from this point. Population, number of Ugandans going up, population going up, this should increase because it would be a drive for government to invest more in electricity to meet the growing population needs. So, but again, it depends on where you're going. A population growing does not assure us of this increase. It could sometimes also lead to a negative in terms from the investment side if the electricity is not done well. So that's why we are saying a determinant. Renewable resources share in electricity generation, the more renewables, other factors constant in electricity generation, the higher would be an increase in electricity security. Energy intensity, the amount of energy used to produce 1 unit of GDP or output. The more energy you use, the lower will be in impact on the reduced electricity security because you are using more energy relative to what you are producing. GDP and investments, these take the same direction. More income or high energy investment should translate into increase in electricity security. And then losses should impact depending on where they come from, technical or non-technical. And finally, energy demand again, which depends on where the rate is going. So to close this assessment, there are tests that must be done for the models I've stated up. And before you do estimate that model, there are requirements for you to do these tests. One of them, or the fundamental one, is unit root test. Once you're working with data which has time varying characteristics, that it requires that the variables you are going to use, the series, the word series here stands for variables, that must be stationary. Stationary means for that fixed period of time, its mean and its variance are constant. If you go ahead and analyze data with non-stationary characteristics, it is still possible, but your findings will give meaningless results because the assumptions behind estimation of these approaches must be that data is stationary. Now, when you test your data or variables individually and find out that a stationary test, there are 3 possible outcomes. It is possible that the ones you have tested are co-integrated or they move together or in one way show long-run relationship. And that's what we call co-integration. You might test and realize that they are stationary in levels, meaning you don't have to do them. The raw data, you test them, you find that they are stationary already. So you just go ahead and analyze. In fact, in that case, you don't need to go ahead and test co-integration. There are sometimes you test and then the variables are unstable, and that's what we mean by unstationary, meaning you have to do something first before you go ahead and use them. And that's what we mean by, so for that one, when you difference once, when you do that something on them is what we mean by making them of that order. So they could be order 1 if you difference them 1 and continuously like that. There are some times when you test stationarity and you have a mix, your variables, some are stationary at levels, some are stationary after differencing, and that is what this approach is all about, the ARDL. It allows for you to analyze to go ahead and make your analysis in case, the variables that you have tested are actually mixed for that. But in reality issues, you want to just find out that your independent variables are not substituting for each other. The optimal lag lengths, I told you we have relationships with the first period, but this tells us, so how many periods back must you go for each of your variables to allow you include them in your analysis? Is it 5 times back? Is it 2 times back? And that's what this particular test does. Once those are done, then you can go ahead and do your estimation. And after you have done your estimation, to prove that what results you have, you also need to do some post-diagnostics, and those are what will give your results some robustness checks. First, you have to check if what you specified or estimated, in most importantly, always remembered as no omitted variables, is actually true or specified, which specifies in that case. The second case is autocorrelation. And here we are talking about residuals from your estimation that are not supposed to be correlated with each other as a requirement for that particular case. The other thing that you must also fulfill or at least check is what we call the heteroscedasticity, in simple terms, that the variance of your error terms or the errors must be constant. If they are not, then your inferences which you are going to make based on the t values or the f statistics will not hold, will collapse, and that's why you have to check. And finally, the model stability, that your estimates that you have fall within those expectations of the model. It's just a bound test, minimum and maximum, or upper and lower limits. Anything out of that it would mean, if they go outside that range, it would mean we can't rely on your model for long run, a planning or configuration is around that. The last objective chair is, which I mentioned, will be to try to simulate electricity expansion capacity for Uganda. And this is using an energy modeling a tool or platform that I'm yet to choose which one to be, but as to try to get that particular. Oops, sorry, Chair, but that's all I have today for taking long, but that's what I have to share with colleagues. I invite your guidance and suggestions going forward into this. Thank you very much.
Okay, Bernard, thank you so much for your presentation. I think members in the platform, we have been listening to the presentation of Bernard, and it will be good for us to give him comments. But before we go to that, I want to acknowledge that we're joined by one of our senior colleagues, Dr. Jolie. Dr. Jolie, you're welcome. So I think let me ask if you have any question, any comment, you can be able to help Bernard to improve on his proposal. But Bernard, thank you so much for that elaborate and clear presentation. It helps now the participants this morning to support you into your journey. So let me open the floor for any comment. I can begin with the students, then I go to the senior colleagues. Any student with a yes? I've seen one participant has raised. You can go ahead and make a comment.
Yes, good morning, colleagues and Bernard. I think I have some few comments on the presentation. One of them is a number of concepts used in the proposal, which I think he can improve. He has been presenting energy security or electricity security has been used interchangeably. And also we need to be clear when talk about electricity security, because we have two components. One is the grid electricity, and another one is the solar electricity, and another one is the generator, using the generator and others. So is not, when you look at his presentation throughout, he has been as if he's looking at the grid electricity. I don't know whether I'm clear on, I don't know what he's looking at. Is it grid electricity? Is it all combined? Because like in the presentation, he was looking at the outages and others, because like we have standalone solar generation, which is not affected mainly by the outages, the cost. You have only one time installation cost, which I think he needs to clarify in his proposal. Secondly, he also needs to define the concept of access. There are two definitions of access. Those house there, you can be, when you read the paper of Alakit and others, they talk about two main access definitions. Those which are connected, you can define that you have access if you are in the area where there is electricity, or you can define access when you are connected. I think that one needs also to come out clearly in the proposal. Thirdly, you also need to be clear on the concept of energy security in terms of weighting. Maybe when I get time, I can discuss with him detail, but weighting has different components. One of the components is have equal weights. Why do you use equal weights? Another area, ways of weighting, you use the principal component analysis. Another area is to use principal score matching. These are all different measures, ways you can weight your data. But I think he need to come out clear why he's using a different approach in weighting the data, and what is the advantage of using one weighting in relation to the others. Another issue which he needs also to clarify more, when you are talking about a construct, when you talk about like energy security is a construct, has indicators, then these indicators are important in the construction. Then it means that your thinking is in relation that energy security can be, when you read about the literature about energy security, there are also unidirectional approach. There is subjective way of measuring energy security, and there are also multi-dimensional way of measuring energy security. So he should come out clearly, why is he going for a multi-dimensional approach of measuring energy security or electricity security than using the unidimension or the subjective way of measuring energy security? I think that should come out very, very, very clearly. When it comes to the issue of the measurement, we need to justify those 5 components of energy security in terms of why is that component important. why does he need to include it as part of the dimension? And to me, you need to come out your contribution in terms of objective 2. Is it that this energy security index has never been produced, or you are extending? And if you are extending, what your contribution in terms of extending the index? I think that one is not also coming out very clearly. Others, I will write to him, and if we can get time, I can help him improve on the concept. Lastly, is the issue on the data. And when you talk about the data, you should also include why that particular source of data is important. Is there no other data sources which can answer the same question?
Okay, Vincent, thank you so much for this wonderful, very constructive comments, which I believe Bernard is taking note. Any other comment from a student? Yes. Bosco, you can go ahead and unmute and make a comment. Bosco, yes.
Very clear. And I want just have one comment. I think Vincent Fred has touched on it already. I seem to agree with Vincent that maybe there is a use of energy security and electricity security interchangeably. I don't know if Bernard, you wish to streamline that, because your presentation is quite clear on electricity security, but it also tends to integrate so much issues of energy security, and yet in your research gap, your contribution is focusing on extending the electricity security into, energy security into electricity security. So it means you indicated clearly that energy security is a bigger component. It's a bigger dimension. And when we look at electricity security, it's a sub-component of energy security. However, when you tend to interchange the two in your discussion, it possibly takes us off a little bit there. And when you introduced the presentation, started direct.
We lost him or what?
Yeah, have we lost Bosco?
Okay, but I think he was emphasizing on the concept which Vincent raised, and I think the good thing, these are your colleagues, you can even make a call and get more clarity on some of the issues. Is there another student before I go to our senior colleagues? Okay, let me take this opportunity to invite senior colleagues. Yes, Sylvia, please.
Okay. Thank you, Dr. Okocha, and thank you, our presenter. This is great work, Ben, I must say. And to me, I just have 2 comments to make. The first comment is about what Vincent has touched on, which is the scope of electricity, because in Uganda, we have both distributed and centralized. You're aware about that. And why am I asking this? Because in the earlier slides, you talk about the current access rate being 42, and I assume that this 42 is also including the distributed. But also when you look at the current report from UBOS, which is the UNHS, I think it goes slightly above 42. Maybe you'll have to reconcile what MEMD is saying and what UBOS is saying, because most cases MEMD picks from UBOS. You may have to reconcile the two, but also you are aware that we have to quote the national statistics anyway. So you'll have to clarify on the issue of scope of electricity. Are you only focusing on the centralized grid, or you are also including the distributed? Because the two might have different barriers and the factors that also influence the security for that matter. Then secondly, at the level of methodology, when you talk about, coming up with an index, and you're already indicating that you have indicators and you'll have weights on them. I think Vincent has touched the component of, what approach are you going to use for weighting these indicators? Are you going to treat them as equal, or are you going to, deploy? And most cases, why I'm asking about this is because if you push out this paper, some of these guys would require that you hold a workshop to debate on the weights that you give these indicators, and therefore how are they coming about. But above that, are you thinking about the cutoff points? When you say, for example, maybe when you come to issues of the quality of governance, what is the cutoff point in there? Have you thought about the cutoff points that you're going to use on each of these indicators to qualify, to contribute to energy security? And then, I think they've been mentioned, the issues of in-dimension versus multi-dimension and subjectivity. All these issues are affecting your energy security measure, and perhaps you have to put across a good debate for you to take on the multi-dimension approach and also to construct an index. And then the other issue, Ben, I wanted to put across is that, or to find out from you, are you planning to use the new index in your estimation, when you're following estimations on objective 2? Because if that is the case, that means you might have to first push out the paper on the index, publish it, and then use it. Okay, so probably you have to think about that. If you plan to use it as a measure for energy security, upon which you're going to do the estimations, then you may have to first publish the measure and then use it in your work. And I don't know if it will not have a time constraint. It's just something you need to think about. Thank you very much, Chairperson.
Okay, thank you. Thank you so much. I now want to go to I will begin with our mentor, then I'll come to Dr. Gideon. Let me begin with Professor Joseph Ntai, then we can have Dr. Gideon Nkozinza. Professor, please.
Thank you, Chair, and thank you, Bernard, for the great job so far done. And I have a few comments, probably one or two, but before I raise those comments, I would like to know from you whether you already have the data that you're going to work with, or you intend to look around for the data. Bernard, do you have the data?
Prof, I can say I have about 75 to 80% of the data.
Okay, and the assumption here is that whether it's 70 or 60 or 20%, you've looked at the data and you've done some bit of analysis of what is contained there before you come up with your conceptualization, right, and the variables that you are actually modeling, because you may come up with a very nice model. Unfortunately, at the end of the day, it might be a little bit hard for you to go ahead and execute the kind of ideas that you have. Having said that, I would really want to thank you, and now I want to comment. Your topic is, can you take us to the topic? And I want to ask you another question. You have energy dynamics and electricity security in Uganda. When you are looking at electricity security, does that somehow relate or equate to security of electricity supply? Bernard, still, if you can answer me before I raise other comments, because they may not be relevant. I want some bit of clarification. Electricity security, does that somehow relate to security of electricity supply?
Very well much related, Prof, but security of supply is just one dimension, the supply, the availability dimension of the entire electricity supply, security. So yes, and it is one of the fundamental dimensions. Before we talk of other issues, electricity has to be available, and availability, we are talking about supply. So there are studies that have equated these two, but they have also been challenged on the same case. But for this study, those are two different things. Electricity supply security is one version of electricity security.
Okay, so if that is the case, then may I assume that in one way or the other, because at some stage you indicated that you will do a systematic literature review, may I assume that you haven't done a systematic literature review? So in which case you may not be aware about your okay. Somebody was trying to disorganize.
Can you say that? Yeah.
What I'm saying that since at one stage you said that you're going to do a systematic literature review, may I assume that you haven't done it, and in which case you may not be aware of how electricity security has been conceptualized? Is that correct? Is that a correct view or wrong view?
I don't want to use your wrong and right words, but the answer, yes, Prof, I have done.
You've done it. May I then also draw your attention to possibly some of the systematic literature reviews that you may not have looked at, which are published as recent as 2021 and 2022 on electricity security, because you did indicate, I think in your either introduction or statement of the problem, that not much has been done in that area, and therefore your contribution is in that area. Is that correct? Actually, that's the one. You said these are not only high, they are still under investigated. And you are citing 2019 when we have recent literature in 2021, 2022.
Okay. For this particular one, Prof, is not electricity security itself, but issues maybe for lack of where to place it, particularly on the prices and
okay.
And connect.
Let's not spend too much time on that. Now go back to the topic. I see you've got energy dynamics and electricity security. May I assume also, because later on when you model, there's a table that you presented that has those antecedents or your independent variables, and I noted, I think 6 of them. You had renewable energy, you had energy intensity, you had economic growth, energy investments, electricity losses, and electricity demand. So to me, those seem to be the independent variables. Is that correct?
Yes, Prof.
Do they translate into energy dynamics? Is that your understanding of energy dynamics?
Yes, Prof. The those factors, those forces that could stimulate or promote or even constrain your dependent variable. But of course, energy sector variables.
May I ask you to take a closer look on that variable,
Okay, yeah.
energy dynamics, how it translates into the other six? I think there might be a conceptualization issue. Think through it. Having said that, let's go to the statement of the problem. And in the statement of the problem, you actually indicate two things. You are saying, yes, if I look at bullet 2, right, actually bullet 1, right, you are talking about constrained economic development, right, due to inadequate energy sector investments. And I assume that you pick that from one of the constructs that you have, energy investments. The second is on low installed capacity, where you have per capita consumption. And then the other one is on perennial outages. Now, when I look at the constructs that you have, right, whereas you talk about investments, the demand, electricity losses actually, I don't know whether they are implied in a way, because you have about 6 of them, right, and here you seem to present the 2, and I seem to get an impression that your independent variables are turning in, are really becoming your criterion variables. Is that a correct thinking, or somehow mistaken? Because your statement of the problem should really try to capture the criterion variable, but you seem to be basing your problem on the independent variables. So if I think you may have to think about it. Maybe you may not have an answer now. Now, if we there's a slide where you talk about the gaps, right, and you talk about practical gap. Can you take us there? You have 3 gaps. Yes, research practical gap, right, and you say electricity availability does not translate into full access, right? Then you have a conceptual gap, electricity security, right, continues to produce controversial debates in literature. But I did not hear any controversial debate when you were discussing, when you were presenting your work. I didn't hear that controversy in your introduction. Is this real, or you are just making a statement that is not really supported by any controversy from literature? Anyway, that is something that you may have to think about, because I did not hear anything about that. And then also methodological gap, inconclusive debates. I did not really hear about those inconclusive debates being brought out. So you may have to really think about that. Now, if we go to, there's a slide I saw there a few minutes ago, and I think you may have to rethink your conceptualization of the, you can take us to that very slide, because before I asked you to come to this slide, you had the slide there that had the constructs of electricity security. I think they are even here. Right, I can see you've got system stability, accessibility, economic impact, and I think literature is awash with the some constructs that you haven't thought about. For example, issues of power quality phenomenon, and the issue of reliability, right? I know that you talk about reliability at some stage, and I know that some of these could actually translate into that. So I really don't know. Did you find some of those constructs like power quality and the reliability constructs constituting security. And of course, under liability, you've got a number of other constructs like the availability kind of things, the capacity, the power capacity. Although at some stage you talk about system stability, right? But you have the capacity, and then if you're talking about the quality, then the issues of voltage, magnitude, and frequency, and the voltage waveform would actually come in there. And I find some constructs here not really falling under electricity security, like the economic impact, for example. The quality of governance, I think you may have to revisit the conceptualization. And as I've told you, there are some systematic literature reviews which are as current as 2022 and 2021, and they've got better indicators of electricity security than the ones that you have there. I think the other one is related to your objectives. Your objectives don't seem to be compatible with the constructs that you have. Just pick objective 4 for purposes of advancing our understanding. Where is objective 4? There's somewhere you talk about objective 4. That is objective 3. No, somewhere. Okay, I think it's the same. Here you call it objective 3, but at one of the slides you call it objective 4. Right.
Right, it is number 4, sorry.
Huh?
Yes, you're right.
4. Now, if you look at the model electricity expansion capacity, now look at your table that has the constructs, your independent constructs. Just flash. I saw it somewhere. Yes, where you have energy dynamics, right? Your energy intensity, etc. Where does that one fall? Your objective 4, which construct?
It is the renewable energy generation, electricity generation, sorry.
Are you sure the two mean exactly the same thing?
Not exactly the same, but what we call them things.
Anyway, think about those.
Yeah, I understand what you have said, though. Thanks.
Yeah, think about them. I have issues with your conceptualization. I have issues related to the problem coming from your independent variables. I have issues of your modeling, not really capturing the independent variables and the criterion variable, but think about them. Okay, I submit, Chair.
Thank you, Prof.
Okay, thank you so much, Prof, for those comments and interaction with Bernard. I think, Bernard, you are taking notes. And
yes, I am.
I'm requesting members to mute their mics. Dr. Gideon, please.
Maybe, Chair, before, there's one I'd forgotten before Gideon comes in. He's talking about an index. And I seem to see challenges with that index. Because when you look at the constructs that constitute the criterion variable, right? And if you look at literature very well, some of the things that have been used to measure that particular construct or coming up with an index, they are not easily brought together in some kind of figure, right? Because if you look at the components, like now, he has quality of governance, he has sustainable electricity generation, he has economic impact, and so forth, assuming that those are the ones he has that he's going to use, right? But I also know that literature is awash with the ideas that seem to deviate from his thinking, which I think he may not have looked at. So you have those, some indicators that have used, for example, the flicker minimization index, right? Especially when they are dealing with the voltage waveform and the voltage magnitude, right? And of course, the other one relates to voltage unbalanced factor. And then when you go to, in some other studies, they have used the total harmonic deviation index, while others have used different aspects. So I'm just wondering how he's going to bring together the harmonic distortions, the flickers, the deviations, and the unbalance, voltage unbalance, and so forth. So I see that unless he's going to do away with some of the items, right, and end up with a few indicators for electricity security, he's likely to have problems at the end of the day. Chair, that's all. Sorry, I had forgotten that.
Okay, thank you so much, Prof. again. And Dr. Gideon, please.
Thank you. Most of the I would like to have also a few that I would like to share with you. But thank you for the presentation.
It's like Dr. Gideon.
One of the
Like your network is breaking, doctor.
You are getting me?
Your network is breaking.
Are you getting me now?
Yeah, somehow, yes. Somehow,
okay.
Please.
So my observation. Okay, thank you. One of the observations is that I think in a problem statement, you're using a bit of qualifiers that is a bit tricky. When you say no empirical assessment on the influence of the threats has been done on security.
Okay, doctor.
I'm sure, but let me finish.
Dr. Gideon.
Yes.
Like you are breaking. I don't know the
connect now to the listener. Okay, let me connect this.
You type the comments, then maybe just type the comments. It looks like the network is not. I don't know whether it's on my side.
But no, I was not also hearing, Doctor.
We are not hearing. It's a general issue.
Okay. Okay, so Dr. Gideon, you type the comments. But Bernard, I must say that I must thank you for your work. I just want to make some comments also. And I think it's about the context. When I look at energy dynamics, look at slide 2. Slide 2. Is that the second slide? Slide 2? Yes, second slide. Where you have pictures. That one, the one you have pictures, that one. The one with pictures, that one. There are people who understand energy dynamics in view of those pictures. How those different sources of energy translate into security, wind energy, and all those other things. So when you talk about energy security, I know diversity of scholars who have argued it in view of how you optimize the use of the different sources, photovoltaic, you see that one, the atomic energy, the wind energy, hydro, and all those other various sources, bio, and all those other things. So there are people who think like that. Again, there's another slide you talked about, and that's another dynamic. I think on the gaps, go to the gaps. Is it on the gaps? Not the, yeah. You see the methodological gap. There are people who look at it also on the basis of aggregated or non-aggregated, or basically macro versus micro. And there are very good examples of countries who have, some countries have pursued the micro, whereby electricity generation, you focus on the different, like now what is happening, whereby you have independent electricity generation. Like countries like Russia, where even private people can generate solar energy and sell. There is that perspective, micro versus macro. And then there are those who believe in combining both. So sometimes when you talk about how do we become secure in terms of electricity, there are those scholars who have pursued that the focus should be macro level. Look at what China is doing. And then also there is another, and all these are displayed in your study. And it's very important for you to be consistent. So it is very important for you to be consistent. So I don't know whether you get to macro versus micro. Should we focus it as providing it at a macro level, or we stimulate the micro perspective? The other aspect also, in terms of the dynamics, I think to a great extent, if you look at your conceptualization, if you remove some of those variables, there is that perspective also, which is also still in your work. So my request to you is very important for you to contextualize what you are talking about, energy dynamics. Because when you is it on the basis of the different sources of energy, how we optimally use them? And of course, there are controversial issues about that. Then the other issue within your conceptualization, I think most people have talked about it. When you talk, what leads to the other? Is it economic growth, which leads to energy security? You need to reflect on that. But also in terms of gaps, where is the theoretical gap? Because you want advanced theory. And I think the theoretical gap, and how are you really highlighting this in your study? They need to come out very, very clear. But I would also love to hear the theoretical gap. And then also when you, of course, you talked about the theory you're using, and I want you to reflect carefully on that, how that theory relates with your antecedents, which you have in the model. But maybe also, and I think Prof really highlighted it, he talked about it, and I think we need to also reflect on it carefully. Look at the purpose of the study and the topic of your study. Look at the conceptualization and look at the objectives, because they need to come very clear. Okay, if you look at your presentation in terms of the conceptualization and look at your presentation in terms of the methodology, to me, I see the way you have captured the critical issues on methodology could maybe from the what you are talking about, the dynamics, and not now energy dynamics, but how this basically, not energy, because when you talk about energy, you are talking about all the different sources of energy. And yet when you look at your conceptualization, is narrow, not, it's just basically electricity. And I think the Bosco also talked about it. But what I must say is that the presentation is very clear. It's a matter of alignment and strengthening, and I think you'll be good to go. But you need to capture those critical comments, especially the issues which Prof raised, the issues you had discussion with Vicent, and some of this, because me understands the energy dynamics on the basis on how these sources translate into electricity. I will be now waiting to see how really we're optimizing solar, photovoltaic, how we're optimizing hydroelectricity, how is it, all this. So, and then now somebody who comes from the perspective of macro would be interested to see how the macro policies are working versus the micro, the individual electricity generators. So I think that could, I don't know whether, Dr. Gideon, can you try to come back again? Maybe the network has stabilized.
Chair, am I okay now?
Yes, now I can hear you,
Oh,
Dr.
okay,
Gideon.
thank you very much. Thank you. I know a number of comments I had. Prof talked about them, although I have some few. Bernard, thank you for the presentation. The few comments, one, I saw that in a problem statement, in addition to the other comments they have given you, the way you are stating this, like when you say no empirical assessment of the influence of these threats, you realize that this is really, you are qualifying the statement. It's a use of qualifiers dangerous. By the time you finish your research, there could be other studies that have done all of this. So how will you defend that? I think you may need to avoid using qualifiers. The other one is I saw where you have an objective of the policy and the non-policy correlates. I imagine, did you try to look at, to review the existing policy in energy and the policy and the non-policy? Have you really reviewed the existing literature and the documentary reviews? I do not even see any policy gap there in your background. So I don't know where this objective is emerging from. I think you may need to think about it. The other one is about, I saw you have also, in the methodology, you have quasi experiment. If I remember, I saw you are talking about the quasi experiment as one of the approach you are going to use. I'm sure you know the conditions that must be fulfilled there. Aspects of randomization. I'm questioning how are we going to randomize? You do not say much about that. First of all, you know, quasi is very good when it comes to studying the behaviors for behavioral studies. Now, you need to think about that. And I saw when it comes to generalization, you seem to be looking at the whole country. So if you are looking at the whole country and you're coming up with evidence-based policy for this country in terms of the energy security, I mean electricity security, how are you going to randomize? You need to really expand more on that. The other one, when I looked at epistemology, yes, you have said something, but if you look at this critically, you did not show us where you're coming from the ontological point of view. You have emphasized on philosophical stance and epistemology, but you know, you can't go to epistemology before you tell us the reality ontological position, your ontological position. Please do something there. The other one, I think, a number of them, I think Prof highlighted a number of them. There's also why you have theory. Let me say something. I had also a comment on that, on theory. Yeah, theory, yes. You seem to be emphasizing that this theory, okay. Now, are you trying to tell us that this theory goes beyond beyond the political and these other ones? I need to be sure. Or you are just, because initially when you started, when you're talking, you seem to have emphasized that the theory talks more of political and military something. May I hear from you, Bernard?
Okay, thank you, Doctor, for even the other comments first. On the theory, it stems or was conceived actually at the Peace and Conflict and Peace Institute in at the Copenhagen Business School in Denmark. Now, the theory purely is developed around security for the state or for the countries, which was about protecting borders and protecting people on military and political grounds. But evolution since then around this theory has been extended to lower horizons, that security does not affect states or countries per se. And these are the wideners. Security actually affects individuals, livelihoods, and societies or communities. That's how it has been, it has evolved.
Okay, thank you. Is that according to your personal critics, or it is
No, not personal critics. It is from the critics as scholars who have expanded it by critiquing it, not me.
Okay, that's fine. So, which means you are trying to say that you went ahead to further look at it, and it has now started looking at these other aspects.
Right.
If they are not to these other aspects, I wanted to see another alternative provision that would strengthen this, because there is that question which somebody raised about the theoretical gap. And if the theoretical gap is a little bit weak, it will still come to you. I submit. Thank you, Bernard. Thank you, Chair.
Thank you, Doctor.
Okay, thank you. I think Bernard, you could make you can highlight a few issues based on the comments, such that as maybe you could be waiting for other comment, but I could give you a chance to maybe to respond some of the comments. And as you respond, by the way, there is also this dynamic of electricity, which I had forgotten to highlight. It seems, okay, it's not here, but if you read out there, you'll find that there is this aspect, transition from data energy sources for generating electricity to that security, where there are some people who believe that it's much more secure as opposed to there's also that context. So you need to really map out your focus. Yes, Professor Laura. And Professor Laura, I don't know, can you come in? Then maybe Bernard can come at the end. Yes, Professor Laura, please.
Thank you, Chair. Thank you, Bernard, for your presentation. I share the views that have already been shared, but just point of emphasis. Most of the things I had noted down have been raised by Professor Antai. So I'm just going to give one area of emphasis. A research is driven by the criterion variable, and it must be clearly conceptualized. Bernard, I want you to go to, I think it was slide 1. Professor Antai already mentioned the issue of conceptualization, but I just want to add my voice to his. You see where that very first bullet, you know, when you get the conceptualization wrong, everything just falls apart. Electricity security. Professor Antai asked you, are you looking at it from the supply side? Other members asked which kind of energy source and so forth. Those are questions that should continuously ring in your mind as you fine-tune your criterion variable. So now here in the first bullet, you are saying electricity security. In this study, you are adopting the definition by IEA 2020, the sustained availability of electricity at affordable and reasonable prices. That's what you say here. But then when you go on to the other slides and up to the end, you seem to have abandoned this. You seem to have abandoned this and gone with something else. So my question then is, have you looked at the IEA 2020 report in detail? Because the IEA provides a different definition for electricity security. Actually, it defines electricity security as the electricity system's capability, the capability of an electricity systems, to ensure uninterrupted availability of electricity. So the emphasis there is the capacity of the electricity system to ensure uninterrupted availability of electricity. And it's the same IEA that goes ahead to provide the dimensions. Some of the dimensions are, I think, there is something to do with operational security, adequacy, resilience, reliability, robustness, stability. But when you read the definitions of those elements, you'll see everything is hinging on the electricity system's capability to ensure uninterrupted availability of electricity. So this is something that I just want you to go and look at, and then you justify why you drop this and go with what you have. Because most of the articles on electricity security that come after that report tend to use the measures of IEA. So here, this is just something for you to think about as you continue to refine your criterion variable. Why do you take A and not B? Why do you define it this way and not the other way? So what drove me to bring this up is that very first bullet in your slide. And then when you read on, you've left out affordability, you've left out reasonable prices. I asked myself, what is reasonable price? Price to me that is reasonable may not be reasonable to someone else. Then I asked myself, are you looking at households? Are you looking at access to every Ugandan, whether industry-wise, whether institution-wise, whether household-wise? Are you limiting yourself to a certain category? These are questions that were ringing in my mind. And then that also takes us to the issue of data source. As you put your variables together, have in mind the data source. That's why Professor Antai asked you, do you have the data already? And then I think Vincent Senono said something about data source again. Why are you using various sources? As you try to put together your variables, you're using secondary data. Have at the back of your mind the point of data analysis. How are you going to amalgamate these various sources to come up with a concrete story? This is just addition to what has already been said for you to think about. Otherwise, I liked your presentation. You presented very well with confidence and passion, clarity. Yeah, but those are some areas for you to continue improving your work. Thank you, and over to you, Chair.
Okay, thank you. Bernard, just...
Yes, Chair, Dr. Okweche, thank you very much. This is, I think, the first time I was sharing my work here on this platform, and I am really happy that I've had these views and suggestions. I really want to thank everyone who has been on this call for all the comments. Some are in the chat that I'm also picking slowly. And these comments for me, largely one, of course, to improve my work, but also to situate my presentation next time, because some of these issues raised actually are available in my write-up, but possibly were not emphasized, which of course I need to. And it has also shaped me for the next presentation where focus should be. I'm taking these really as points of reflections. This is, I know some of the things to recheck, like Professor Ruby has mentioned, and the comments raised from Vincent up to the last provider today. I've noted them for reflection. Responding to them now may not necessarily be the issue here, but possibly two things, because you're going to continue, of course, interacting with you. Two things maybe that I should have mentioned. On one, focus of my study, the approach here, electricity security has been largely analyzed at two levels, what we call the micro level, including institutions and households, these which are called units, but also at the macro level. And predominantly, even in literature right now, is the macro space or level. I am taking on the macro level perspective, meaning a national level approach to deriving this rather than the micro level for some justifications, including data availability issues for some of the indicators. Professor Ntai raised some of the indicators that are captured or explain this issue at the farm or micro level, so to say, and they do not measure or cannot be aggregated for the entire electricity system base. The other issue that came up, I think for Vincent, which I also noted that I didn't possibly talk about it, was the issue of assigning weights. Yes, Vincent, you're very right on weight selection. And before you even go ahead and define this, the last stage, second last stage is weighting. Now the approach is, like you stated, that are used for weighting indicators once you have reached to that stage. Focus here or guidance and empirical studies have demonstrated two things. In a situation for your multidimensional variable, where the constructs or dimensions are compensatory. Compensatory means here one of the indicators, dimensions can substitute the other to the extent that if you removed it, you'll have no loss or probably relatively no bigger impact on the outcome of your variable. Then there are instances where the indicate dimensions are non-compensatory, meaning they are not related and therefore cannot be substituted for each other, but they are all relevant. Now, for immeasurable phenomenon like electricity security, where you cannot easily pin it down to one thing or two things alone, and they are non-compensatory, for instance, for my case, the weighting system, because you are not going to say this one is more important than this one, that's where the equal weighting system has been largely adopted. But again, from comments, of course, which I've had, I have to still go ahead and recheck that these dimensions are not sufficient in themselves, or if they are only these, then a reason why I'm keeping it to this. So for this case, the weighting system would be equal weights, and for that justification if you have, but I'll find you for, of course, an extended chat on that. Honestly, for the rest of the issues, these are real reflections for me to take back with me, where I was not clear, maybe bring them out and make this better. Chair, I don't want to stretch this further. I want to thank everyone again for being part of this interaction.
Okay, Bernard. Thank you so much for that. And I really believe that you're in the right direction. I have confidence that you'll be able to do a good job. And also, I must thank everyone who has given a comment, both in the chat room, and I must thank everyone in the call for the time spent. I think this is a morning well spent. At this juncture, I think we should come to we should close this this session, and I want to invite Dr. Goretti to make some closing remarks, and then with a word of prayer. Dr. Goretti Chione.
Thank you, Dr. Okoche, and I'd like to thank all colleagues that have made comments to Bernard. Bernard, thank you so much for the good presentation with the clarity and the confidence. I've liked the unique area of your study, which is electricity security. Most studies that we've been looking at to do with the access, affordability, and so on. But this is a very unique area of study, and you've done some good work so far. Take on the comments given, and you will be just there to produce a very good piece of work. Thank you, our mentor, Professor Ntai, for this continuously, and all the members that have been on this call this morning. In prayer this morning, we thank God for the sharing of knowledge. We thank God for the gift of life and the ability to come together every morning on Sunday to share all that is important to all of us. We pray for more blessings in this, Father Lord, and we pray for the continuity of this forum. In your name we have prayed. Amen.
Blessed Sunday.
Nice Sunday.
Enjoy the remaining part of the weekend. Thank you.
Sunday too.